Okay, so today we will learn about some force system, some vocabulary such as push, pull, action, reaction, etc. So, what is a push? Push is the force which acts on a body at its back, as seen in this figure, at its back to move it away from the source of application of the force. Okay, so push is the force which acts on a body at its back to move it away from the source. Oppositely, pull is the force which acts on a body at its front to move it closer to the source. As seen in this figure, pull is the force which acts on a body at its front to move it closer to the source. Now, what is action? Action is the active force and reaction is the reactive force. When a body is placed on a horizontal plane like this, the weight of the body W acts in vertically downward and a reaction force R acts in vertically upward direction, where W is called as the action of the body on plane and R is called as the reaction of the plane on the body. W action of the body on the plane, R reaction of the plane on the body. Okay. Next term is tension. Tension is the pull which acts on the string, rope, rod, or body, etc. It is the pull force. Okay. Tension is the pull force. Conversely, compression. Compression is the push force which acts on the string, rope, rod or body. Okay. So tension is pull force and compression is push force. Now, a body is said to be in tension if it is subjected to two equal and opposite pull force. A body is said to be in tension if it is subjected to two equal and opposite pulls, as seen in this figure. Similarly, a body is said to be in compression. A body is said to be in compression if it is subjected to two equal and opposite push force. Okay. Next term is thrust. So, what is a thrust? Thrust, when a fixed surface is acted upon, when a fixed surface like this fixed wall is acted upon by compressive force, push force, that means push force, then that compressive force is called as thrust on that surface. Like this figure, thrust is W, compressive force acting on the fixed wall. Fixed wall is the fixed surface here. Okay, so you push about some fixed wall and then that push is called thrust. Okay, now let us discuss some principles of force systems. There are certain principles on which a force system works. Number one, principle of equilibrium, law of force. So look closely at this figure. Principle of equilibrium, law of force. Imagine a body at point A force P is acting outward direction, and at point B a force Q is acting at outward direction. Now if P and Q are equal in magnitude and opposite in direction like this and collinear in action like this, then we can say that this P and Q has established an equilibrium in the body. So in theory we can tell that two forces can be equilibrium only if they are equal in magnitude, opposite in direction and collinear in action. So this is the principle of equilibrium, law of force. Okay. Next is principle of transmissibility of a force. Principle of transmissibility, that is the ability of transmission of a force, transmission from one point to another point along the line of action of the force. It is simply the transmission of a force, such as look at closely this figure. At point B, a force F1 is acting outward in our outward direction. If we say that another force F3 is if we transmit this F1 into some other place along this line, along this dotted line, and give it a name F3, then we can say that F1 is equal to F3. If it is F2, then F2 is F3 is equal to F1. F2 is equal to F3 is equal to F1. Okay. So if the point of application of force, here point B acting on a body is shifted, the point B is shifted to this position or that position along the line of action without changing its direction. I am not changing its direction. Let us suppose this point B is shifted to point A or point D, etc. along the line of action and without changing its direction. Then the effect of the force F1 or F3 or F2, whatever, effect of the force remains unchanged. Effect of the force remains unchanged and the equilibrium state remains unchanged. This principle is known as principle of transmissibility of force. Principle of transmissibility of force. Okay. Next is principle of superposition or law of superposition. So in mechanics, the law of superposition is stated as the action of a given system of forces on a rigid body. The action of a given system of forces on a rigid body is not changed by adding or subtracting another system of forces in equilibrium. The action of a given system of forces on a rigid body is not changed by adding or subtracting another system of forces in equilibrium. Look at this figure. This is a body. At point B, a force F2 is acting outward direction. At point A, another force F1 is acting in the outward direction. Now to balance this force F2 at point B, a force F3 is acting inside the body. Okay, inside the body, and F3 is equal to F2, that is equal in magnitude and opposite in direction, and they are collinear. So obviously F3 and F2 are establishing equilibrium at point B. Now if we subtract this force system, F2 F3 force system, if we subtract this F2 F3 force system from F1, from this body, nothing will happen. That is, the action of the force F1 will remain unchanged. Okay, action of the force F1 will not be influenced by adding this F2 F3 couple, F2 F3 system, or F2 F3 or subtracting F2 F3 system. Action of F1 or influence of F1 will not be changed on the rigid body. That is, the action of a given system of force F2 F3 on this rigid body is not changed by adding or subtracting F2 F3 in equilibrium. Clear? So if F2 and F3 were not in equilibrium, then adding or subtracting F2 or F3 from F1 will bring some change. It is because F2 and F3 are in equilibrium, we can surely subtract or add these to F1. Okay. Now another term is free body diagram. In mechanics, what is free body diagram? A body is said to be free body if it is isolated from all other connected bodies and supports. Free from all other connected bodies and supports. Suppose this figure 1. This is a body on some plane. Free body diagram is like this. Just forget about the plane on which the body is sitting. We have to draw just the action force W and the reaction force R. Okay. Similarly, here in figure 2, a body is in between some angle, some inclined plane. Two inclined planes are there here. One inclined plane is here, and another is the floor, and the body is situated in between the inclined plane and the floor. Now the free body diagram, FBD in short, will be like this: action force W, reaction force R, and another action force is here coming from the inclined plane uh, uh, in the inward direction. Okay, so this is the free body diagram. Free from all other connected bodies and supports, but not free from the forces exerted by the connected bodies and supports. We have to draw the forces, different forces. This is the free body diagram. So that's all for the initial vocabulary, and now we shall study the resultant of vectors. Okay, thank you.